Welcome to the seminar series Sewer and Pipeline Engineering. My name is Bert Bosseler. I am Scientific Director of the IKT Institute for Underground Infrastructure, and this is the first lecture of the series. On this slide you will find some information about me and my activities as well as my contact details. If you have any questions, please do not hesitate to contact me. So you may ask, where is IKT, my institute, located? Well, it's just north of Africa, west of Russia, on a small peninsula. We call it Europe. Many funny languages are spoken on this continent. However, I will try to do this seminar in English so you can better follow my words. IKT headquarters are in Germany, and we have a second laboratory in the Netherlands. Both are located where you see the red arrow. These two places are close together right on the border between Germany and the Netherlands. And in addition, we also have an office in England close to London. And with that, I would like to start my introduction. First of all, there is the question, what exactly is the IKT? And what are the Institute's main focuses? Because much of the content of this seminar series is based on experiences that we have made at IKT ourselves or together with partners in our IKT projects. The second question is then, what do we actually understand by the subject area sewer and pipeline construction or pipeline engineering? It is just about laying pipes, or is there perhaps more to it? Yes, and finally we will ask ourselves beyond the basics, which questions are of particular interest to us, both in terms of engineering and economics. But let's start with IKT. Let's take a closer look at our institute. Maybe the most important thing to know about IKT is the following. The IKT is a neutral, independent and non-profit institute. And that's because the owner organization is the IKT GmbH. That is a German type of non-profit company that is economically independent and autonomous. Instructions from outside, for example from a public authority, are not possible. The company can decide for itself how and for whom it works. Another special thing about IKT is that the shareholders are two associations. One is the Association of Network Operators, with over 100 members from municipalities, public utilities and water associations. The second shareholder is the Association of the Private Sector, with over 50 members from companies and industry associations. And both shareholders, that means both associations, have stipulated in their statutes that they ensure the neutrality of IKT and that they won't exert any influence on the Institute's work. And that is really something special because, as you know, that is normally what shareholders want to do. They want to exert influence and control the business. However, that does not exist at IKT. We are neutral and independent. What's more, in Germany, the state can also grant special recognition in tax law. After all, IKT is a non-profit organization because its activities are geared to the common good, such as environmental protection, research and education. So, where is our work most needed? Well, whenever quality in the network is at stake. And this applies to all phases, from construction to operation, right through to renovation. Quality is our main topic, which we examine together with the network operators. That is, the municipalities, the public utilities and the water boards. In research projects, we identify quality influences and we search for new solutions. In product tests, we compare the basic quality of products, and in expert opinions, testing and consulting, we also take a close look at quality in individual cases. In doing so, we naturally draw on the expertise of our employees and our testing technology. But we are also part of a strong network in science. After all, IKT is not only called an institute, we are one. We have been an affiliated institute of the Ruhr University in Bochum since its founding, which means we have a clear cooperation agreement and access to the university's infrastructure. In addition, we are an affiliated institute of the Westphalian University and partner institute of one of the universities in Munich. And in teaching, we also cooperate very closely with other German universities, such as the University in Hanover, the University in Weimar, and the newly founded Ruhr West University of Applied Science. The IKT was founded in 1994. And here we see the headquarters in Gelsenkirchen, Germany. It consists of offices and event rooms, but also, and this is the special thing, also a large test hall right next to it. This means that when we research and test, our employees, our partners and clients can always experience this at first hand. Events and discussions can thus be directly combined with practical impressions from the test hall. You can see an impression of this technology here. The concept is we want to recreate everything that happens underground on a scale of 1:1. And a lot happens underground, both during construction and maintenance of the sewers and pipes. There are countless interactions between the ground, the components, the groundwater, and also the roads and the traffic on the surface. In the pictures on the right, you can see how we ourselves can recreate the drilling and jacking of large diameter pipes in our experiments on a 1:1 scale. As a result, the cities and municipalities then know what risks are to be expected during the construction or rehabilitation of sewers and pipes. And they can reliably decide what quality they want to demand and what they want to pay for the pipes and construction technology. However, the whole thing not only affects the construction but also the operation of the networks. Below left we see a large diameter pipeline that was installed on our IKT site. Today a dam made of various types of soils lies above it, and in this section we are testing inspection technology, we are testing also, for example, other techniques to determine the condition of the pipes or the condition of the soil during operation. So we can see that practice is the main focus of our IKT. Science and experimental technology are just the means, but practice is the end of our projects. And of course, we continue to develop our testing technology. Current problems such as climate change and heavy rainfall also require new infrastructure solutions. We are therefore currently building a new test facility with which heavy rainfall events can be simulated on a scale of 1:1 over an area of 200 square meters. We are interested in runoff formation, runoff concentration, and what the underground technical facilities can achieve to manage possible flooding problems. This includes, for example, drains, gutters, shafts, manholes, pipes, and water-permeable pavements. And the facility that you can see on this picture is primarily a new efficient research infrastructure. What we are going to research and test with it depends on the future questions and problems of the network operators. And since we are oriented towards the general good, you will find many of our results as free downloads on the internet. Typical examples are our product tests, our quality reports, and of course all our research results. We always try to get the release for publication of the results from our clients, and especially the federal, state and local authorities are very open and happy to do so. Once a year, we also award a prize for special achievements of the municipal network operators. It's our golden manhole cover, which you can see here on the bottom left. So if you or a colleague is responsible for a municipal sewer system, and if you have set up something particularly innovative and citizen-friendly, go ahead and apply, wherever you come from. Now we come to the actual topic of this seminar series, sewers and pipelines. Here we see a view of our city, not only of streets and buildings, but also of the area that interests us most in this seminar, the underground. Almost our entire supply and disposal infrastructure is located there, under sidewalks and under streets. And this example shows how a large German utility company, for example, imagines it. We took the picture from a company magazine with the kind permission of RWE. But we changed the picture a little. We added the trees in the middle afterwards. What we see is a whole collection of underground sewers and pipes. There are yellow gas pipes, water pipes, electric cables, and even the telecommunication cannot be missing. In the middle of the street, the large rainwater collectors and the sewers are located at great depth. And on the left, we see more main pipes for drinking water and gas. And all these pipelines then have to have laterals to be routed into the houses on the sides. And then under the crossroads, it also gets really narrow, of course. This underground space in our cities with all its sewers and pipes is our topic. How can we build such an infrastructure? How can we operate it? And of course, the big question, how can we maintain or even renew old structures? We want to address all of this in our seminar. In particular, we will deal with technical questions. For example, what pipes and construction methods are available? How can we dig a trench? Or how can we build and renovate without trenches? But we will also address organizational and economic questions. Who is actually responsible and which procedure is actually economically sensible? The starting point is, of course, the question, what are our actual goals in the construction and maintenance of sewers and pipes? Or to put it in another way, what functions does an underground sewer or underground pipe have to fulfill? Here we can distinguish between three core functions. Firstly, operational safety or reliability. Secondly, stability or structural safety. And then, of course, leak tightness. This applies to all sewers and pipes, regardless of what is actually being transported. In concrete terms, operational safety means that the pipeline must reliably do what it was built for. First and foremost, this means that the medium to be transported must flow through the pipeline without any problems. This means that the pipeline must not be clogged. A sewer must have sufficient gradient, and a drinking water pipeline must not be dirty or even contaminated. During operation, the pipeline must safely perform what the operator and what the customer expect. Otherwise, we don't really need it either. Reliability, that means operational safety, and thus also performance, are the actual purpose of the pipeline. The two other criteria are added, that is structural safety and tightness. Of course, both can also have an influence on operational safety, but we can understand them here as criteria in their own right because they have their own significance. So let's talk about stability or structural safety. A pipeline must not only be stable from an operational point of view, but it must also be stable because a collapse can pose a serious threat to the environment. If a large sewer collapses in the middle of the road, huge holes can also open up in the road, and the neighboring buildings are then quickly endangered. If a drinking water pipe breaks, the escaping water can wash away all the soil on the street. This is very dangerous. Yes, and the leak tightness, well, it can also be very dangerous if pipes are leaking. In that case, what flows through the pipe is no longer cleanly separated from the environment. The transported medium can escape from the pipe, but foreign matter can also enter the pipe. And nobody wants germs in the drinking water. Nobody wants sewage in the groundwater. And nobody wants an inflammable air-gas mixture in the underground. And if deep-seated sewers are leaking, also groundwater can penetrate into the sewer. Also, this is a problem when sewers and treatment plants are overloaded with groundwater inflow. So we see operational reliability, structural safety and leak tightness. These are three technical criteria that must always be fulfilled. And for us, always means over the entire planned service life of the network. And there we are then also with the economic criteria. Also here, three substantial criteria are to be called: the service life, the costs, and the lawfulness. Service life is a very important concept here. Every network should be planned in an economically sensible way for a certain service life. And all technical services must be provided over this lifespan. The costs for construction, operation and maintenance during the service life then play a major role in economic efficiency. Well, and what role does law play? Well, as external boundary conditions, the legal requirements can have a major influence on profitability. And this can affect all phases of construction, operation and maintenance. Let's just think of the requirements for occupational safety. In our seminar, we want to keep these things, the technical and the economic requirements, always in mind. After all, everything we do takes place within this framework and is of great importance for life in our cities. In the end, we need a functioning supply and sewer system as part of our quality of life. People and companies depend and rely on it. And in terms of economic efficiency, there are immense assets underground, which we have to take care of. Some time ago, we at IKT took a look how these assets are distributed for Europe. The survey was based on published statistics and our own data. Of course, there are also more recent figures, but they are not so easily comparable, so I will stick to our sources here, so still for the EU of 28 members. What is the situation in detail? Well, underground transportation routes account for less than 10% of the total underground assets. This is certainly below what many people would think, because the use of underground transport is usually an extensive experience. Subways, train and road tunnels are widespread in Europe and millions of people use them every day. However, though the costs per meter of track easily run into the millions, the total construction costs are comparatively low, because the total length is not as high as in the other networks. The supply networks for gas and water, in contrast, have enormous network lengths. However, for these lines, the construction costs are not as high as for the sewers. Many supply lines are located in the sidewalk area and the installation depths are usually shallow. All these networks do not even reach half of the assets. So, who is the real asset giant here? Well, with a replacement value of more than €1 billion, that's the sewers. On the one hand, the public sewerage system has a significant network length. On the other hand, the specific construction costs per meter are significantly higher than in the utility sector. This is because the sewers usually have large diameters and are located deep in the middle of the road. According to our surveys, for example in Germany, about €4 billion are invested every year for a connected population of 80 million. If you summarize the replacement value of sewage and water pipes together, you can also see that everything to do with water definitely dominates the underground in our European cities. It amounts to almost €2 trillion. However, there are also other networks, transport pipelines, district heating lines and cables. And district heating and cables in particular are growing strongly due to developments in energy and telecommunications. So, what issues and questions do we want to focus on in this series of seminars? Finally, let me give you an overview. We have already recognized construction, operation and maintenance of the networks as our main topic. The networks must be stable, reliable and leak-proof over the entire service life. And all this at reasonable cost within the legal framework. That applies to every single network. And even more, all infrastructure networks also interact with each other and other structures and other users. On the one hand, there is the interaction of the overall system of pipes, soil and roads. The whole thing is a highly sensitive engineering structure. After installation, the resulting pipe soil structure must not only be self-supporting, but also provide an even foundation for the road structure above it. We want to avoid subsidence at all costs, and yet the whole thing must still be easily accessible in the future, for example, to make connections or to do any repairs. And a pipeline, of course, only makes sense if there are connections. How can we make these connections in a reasonable way? Many sewer laterals used to be connected by simply breaking the main line and pushing the connection in. And other connections do not withstand the earth loads and break off. And that leads us to one big question. How can we repair such connections and all other damage scenarios in the underground without having to dig up the whole road? There are many interesting inspection and construction methods that work underground without trenches. And the quality of this work is also of particular interest here. Well, and then, of course, the groundwater. Groundwater is not only an external static load for all pipes, it also causes buoyancy. And groundwater can also lead to further problems, especially in sewers. If a sewer is leaking, groundwater penetrates into the sewer and high quantities of water can flow in. And then they overload the entire system. So in combined systems, in the event of rainfall, there is no longer enough space for the rainwater and even backwater can occur. Well, let's seal the sewers, you could say, but even that is not so simple. First of all, it is not so easy to seal a pipe, for example with a robot, when water is flowing in from the outside. Secondly, new problems can arise. If the sealing is successful, the groundwater level will rise again, and this can have negative effects on surrounding structures. Uplift and wet basements are just examples. Further interactions occur during operation. Sewage or odors can come to the surface from sewers. And there is often an intensive discussion about how sewers and pipes can best be cleaned and operated. Yes, and finally, a very special topic. There are also many interactions between trees and sewers or pipes. Roots look for space in the underground, and they find it especially in the vicinity of pipes. And that brings risks. For example, roots can pull on a pipe, for example, when wind blows on the tree. Or a root grows into a pipe joint and clogs the pipes. So we have to ask, what role does pipe and soil quality play here, and how can risks be reduced? And finally, how can we repair damage from root intrusion? And please don't forget, we also need trees in our cities because they are part of our quality of life and help us with heat and other climate change issues. However, we also have to be aware of all these possible interactions, just how we can see it on the next picture. Anyone who wants to build or renovate something in the existing underground today will hardly find enough space. Pipes lie crisscrossing the underground, and where there are no pipes, there are roots of trees and of other greenery. And in some cases, hardly anyone knows where all these structures are located. This becomes particularly clear when, as here on the bottom right, a new pipe has been shot through an old pipe. Obviously, when drilling the new pipe, one did not even suspect that there was another pipe down there as well. Such cases are not uncommon, and they go into the thousands. And here, of course, there are questions of responsibility, of organization, and of management of the whole life cycle of these underground systems. And in this seminar, we especially want to look at the life cycle question. What we will look at in detail, that is the products and components we use in the networks. So for example, components like pipes, manholes and connections, and the necessary trenchless rehabilitation techniques, of course. With these components and techniques, we can build, we can operate, and we can maintain and rehabilitate the networks in a reasonable way. And for us in our seminar, we will focus on the quality requirements and the quality assurance that is needed to be successful. And finally, we will ask what actually happens at the end of the service life. Is what we build flexible enough to be able to adapt to future requirements? Asset management is the key word. That means a real asset management over the entire life cycle. So we see there are many exciting topics which we want to understand better together in this seminar. I'm very much looking forward to this. Hopefully we will meet again, and maybe you would like to meet me at IKT or in a video chat. I would be delighted. You already have my contact details. You are always welcome. Thank you.